Hey everybody, so this is a new experience. We'll try this video notes out here and see what you think. We've already done the first couple pages of this. So skip down, the first couple slides. Skip down to this slide here. And since we didn't have a lot of time to do these two slides in class, I want to do them now. So you have a couple choices. You can watch the video and then re-watch and do the notes. You can stop and start the video to do the notes. Whatever works best for you. Okay, so on this slide we want to determine whether the line passing through 1, 2, and 7, 5 is parallel to the line given by that equation. So the thing we have to remember is that parallel lines have the same slope. Right? And the slope of this line right here is 1/2. So the question is, if we find the slope of the line that goes through the other 2 points, will it be 1/2? So let's find the slope. We know that slope is equal to y2 minus y1 over x2 minus x1, so we're going to use that to find the slope that goes through these 2 points. So you can see if I subtract the y's and subtract the x's, 5 minus 2 is 3, 7 minus 1 is 6, and that gives me 1/2, and that is the same as that. They're equal. So therefore, the lines are parallel. Okay, now we're going to do another example that uses perpendicular lines. Okay, so next slide we're going to determine whether the graphs of 2x plus y equals 10 and y equals 1/2 x plus 9 are perpendicular. So the thing we have to remember here is that perpendicular lines have the slopes that are the negative reciprocals, which means that they multiply to -1. Remember, you can stop the video at any time if you need to catch up on the notes. Okay, so we have 2x plus y equals 10, and we want to find out its slope. So we're going to put it in y equals mx plus b form. Subtract 2x from both sides. Plus 10, whoops, and so the slope here is -2. And for the other line, y equals 1/2 x plus 9, the slope is 1/2. So are these two numbers negative reciprocals? Yes, they are, and we can prove it by multiplying them together. So -2 times 1/2, we can put this over 1 if we want. That helps you. -2 times 1 is -2. 1 times 2 is 2. That equals -1. The lines are perpendicular because their slopes are negative reciprocals. Okay, on the next slide, in class on Friday, the warm-up was finding x and y intercepts. And we know that the x-axis is called, the place where the line crosses the x-axis is called the x-intercept. And we want to know what is the value, the y value, at the x-intercept. So to find the x-intercept, all we have to do is let y equals 0. Because we talked about how if you have a graph, right, most graphs have an x and y intercept. So in this graph right here, the green line, the x-intercept is right here, and that happens when y is 0. So down here in this example, we're going to find the x-intercept, which means we're going to have something 0, right? So we put 0 in for the y, and that becomes 0, so we get 3x equals -15. Divide both sides by 3, and we get x equals -5. So the y-intercept is -5, 0. So one reason why the intercepts are so sweet is because we can graph really easily with this. So here's an example. Oops, sorry. We take the equation 2x minus 3y equals 6. So we want to find the x-intercept and we want to find the y-intercept. The x-intercept happens when y equals 0, and the y-intercept happens when x equals 0. So notice I rewrote the equation in each case. And so for the x-intercept right here, I'm going to let y equal 0. So I'm going to write my equation, 2x minus 3 times 0 equals 10. So this term drops out because it's 0, and I get 2x equals 10 and x equals 5. So that's my x-intercept. Now I want to find my y-intercept. To do that, I let my x term be 0 and solve. So I get, this guy becomes 0, and I get negative 3y equals 10. Divide both sides by negative 3, and I will get y equals negative 10 thirds, which is negative 3 1/3. So now I have my x and y intercepts, and I've got 2 points. So I've got 5, 0, and I've got 0, negative 3 1/3, and we know that you can graph a line with 2 points. So graph those 2 points on the graph. So you can see I graphed those 2 lines where the pink points are. I graphed those 2 points where the pink points are, and now I'm going to draw a line through them. There's my line. Remember, it goes on forever and ever. So it has arrows on both ends. And that is how you graph an equation, a line, using x and y intercepts. So it's pretty handy. Now, here's the next one. You try this one, and then, so stop the video, try this one, and then you can restart the video to check it. Okay, so there we go. I got an x-intercept of negative 5, 0 right here through this process, and I did a y-intercept, and I got 0, 2. I graphed those here and here, drew the line, and there's the graph of my equation. So that's one of the most useful things about the x and y intercept is for graphing. The other thing I wanted to mention about this is you see this negative minus 5y right here and the negative 10. Be really careful with your signs that you don't drop those subtraction signs. Okay, so now I want to talk a little bit about standard form. Standard form is another way to write a linear equation. And standard form is simply this, right here, ax plus by equals c. And an example of it would be just something, it's very straightforward, like 3x plus 5y equals 8. That's an example of standard form. This is the a, this is the b, and this is the c. So you'll notice that in the description here it says a, b, and c are real numbers, and a and b are not both 0. Because if they were both 0, then you'd have the x crossing out, dropping out, and the y dropping out, and you'd have 0 equals 8, which is not true. So if you need to put an equation in standard form, like it says here, all you have to do is rearrange this equation so that it's in the form the x term plus the y term equals the constant. So let's do this one right here. All we need to do really is get the 4x on the other side, because we have to have the x and the y on the left-hand side in standard form. So I've got negative 4x plus y equals negative 7, and there we are. That's standard form. That's all there is to it. It's rearranging the equation. Okay, so to sum this up, when is the slope-intercept form useful? It's useful if you know the slope and y-intercept, right? Because then you can write an equation. It's useful for graphing because you know the y-intercept, and then you can graph the slope. Okay, you know the y-intercept and you can graph the slope rise over run. When is the standard form of an equation helpful? It's helpful when, for graphing by x and y intercepts. And as you'll see in our next chapter, it's really helpful when you have systems of equations. And as we go along in algebra, we'll see other ways in which it's useful.